Hello everybody, it's Miss Kelly and I am going to read you the book Robots. This is a favorite in our household because we can learn some pretty neat information in this book. There's a really neat robot right there. We've got our table of contents here, which tells you what is included in the book and what pages things can be found on. Let us begin. Imagine robots. First you have to imagine something, then you can make it real. That's what people who design and build robots do. Roboticists imagine all the ways robots or bots can help us. A designer creates drawings and models of a bot. They set a goal. What will the bot do? How will it be built to do its job? With a team, they turn their ideas into amazing robots. New word, roboticist. A roboticist programs or gives instructions to the bot. Say it out loud, roboticist. Neo is a smart, friendly, human-like bot. Neo was programmed by roboticists to walk, talk, and play RoboCup soccer. Roboticists design robots in different shapes, sizes, and materials. Some bots can walk, others can roll, swim, and fly. Come meet some cool, helpful bots. Sapphire can locate fires and see through smoke. The firefighting bot will one day help sailors put out fires on ships. Free-flying smart spheres help with tasks on the International Space Station. Elephant-eared Hello Spoon feeds children who cannot feed themselves. That's pretty helpful. Kismet was designed to relate to people and learn from them. Kismet has learned about feelings. It makes faces to show it is happy, sad, or surprised. He looks happy there. Bear. Bear finds and carries disaster victims and injured soldiers to safety. What an important robot is this guy. How robots work. Most robots have similar main parts. Sensors let the bot see, hear, and feel what is happening. A computer brain or controller takes in that information. It signals actuators, parts like motors, when to move. A battery or other power source gives the bot energy. Microphones let Neo hear and talk. Neo's camera eyes see and track faces and objects. New word, actuator. An actuator is a part that makes a bot move. Say it out loud, actuator. Sensors let Neo feel pressure and touch. Playing soccer tests Neo's skills in using its sensors to find the ball and teammates. Humanoid bots. Some bots look and act like humans. It's tricky to get bots to balance on two legs without falling over. Our brains adjust our bodies when we walk. Robots need a lot of programming to walk upright. They also need sensors to see and feel the ground. Honda's Asimo is a 4-foot, 3-inch humanoid bot. One day Asimo will help people in their homes. Asimo can run and hop. Asimo can climb stairs without stopping. Asimo can serve you a drink. 4 sensors in Asimo's hands keep it from crushing this cup. I love you. Improved finger movement helps Asimo sign. New word, humanoid. A humanoid robot has a human shape. Say it out loud, humanoid. Factory bots. 90% of all robots work in factories. Bots help workers to do dangerous or difficult jobs. They repeat the same job without getting tired or hurt. Car building bots weld metal parts together with lightning speed in this picture. It's a fact, about 1.5 million factory bots are now working in the world. Yumi is a new high-tech bot designed to work alongside humans. Yumi stands for you and me. Workers teach Yumi tasks by moving its arm through each step. And this is Yumi Robot. Improved sensors help Yumi see, grip, and place delicate laptop and smartphone parts. Robots in space. Robots are great for exploring space. They don't need air, food, or water to survive. Robonaut 2, or R2, is the first humanoid robot in space. R2 works alongside astronauts aboard the International Space Station. R2 hands move almost like human hands. R2 grips and uses tools to help make repairs. The crew can control the force in R2's arms and hands. R2 can lift 20 pounds in each hand. R2 may one day explore Mars while attached to a four-wheeled base. New word, robonaut. A robonaut is a robot astronaut. Say it out loud, robonaut. NASA's Curiosity rover, a mobile bot, is looking for signs of life on Mars. Dr. Vandy Verma, space roboticist and rover driver, puts on 3D goggles. She views pictures Curiosity sent. There's a time delay between Earth and Mars. Our team can't see what Curiosity is doing until after it's done. We give the rover goals. It takes pictures and follows the plan on its own. If Curiosity runs out of things it knows how to do, it stops before its goal and calls home. Whoops. It's a fact. Curiosity is the first robot on another planet to drill into a rock to collect samples. And there he is. Curiosity's 17 cameras allow it to see and take pictures. The rover uses its antenna to talk with Earth. The rover zaps rocks with a laser. Curiosity's 7-foot-long arm drills and scoops samples. The rover tests rock and soil samples in its onboard lab. Here's another look at him up close. Robots in medicine. Robots are helping healthcare in awesome ways. Sometimes doctors need a helping hand. The robotic arms in the Da Vinci system are fitted with tiny tools. Doctors can control the arms remotely to perform surgery while watching on a 3D screen. There they are, looking at their screens. And there is the robot and its arms helping in surgery. ReWalk is a powered robot suit that is changing people's lives. It helps people who cannot walk to stand up and walk. ReWalk has an onboard computer, motors, and sensors. Don't like that needle? Your friend Neobot coaches kids and helps them feel comfortable when they visit the doctor. That would be really neat to interact with a robot when you went to your pediatrician for appointments. Ideas from nature. Some robots look like humans while others look like animals. Roboticists design these bots by studying the ways real animals look, move, and act. A snake bot can slide into places. The snake bot can see inside pipes. Snake bots have segments or sections to help them move like real snakes do. A snake bot's light and camera let human controllers see what the bot sees. There's a snake bot. A snake bot can slide into places people can't go, twisting its body from side to side. A snake bot can slide into a collapsed building to search for people. The bot can also slither into a pipe to inspect a power plant. Cyro is a jellyfish bot with a squishy, rubbery body. Motors help Cyro move through the water like a real jellyfish. Cyro will study ocean life and keep watch over our oceans. That's really awesome right there. Wires from a battery connect to motors to move Cyro's 8 arms. The cheetah is the world's fastest land animal. Cheetah Cub Bot runs very fast, climbing over things in its way. Its legs copy real Cheetah Cub legs. One day, Cheetah Cub Bot will explore rough stretches of land. There we have the real cheetah, and then the cheetah robot. In tests, the bot ran almost 7 body lengths in a second. Wow. Tiny bots. Scientists are looking at ways tiny bots can talk and work together with shared goals, like ants and other insects do. Kilobots are only the size of a quarter, but 1,000 of them together form a mighty swarm. They work together to complete tasks. The bots vibrate to move and light up to talk to nearby bots. Groups of kilobots may one day help clean up oil spills. Bridge inspector bots also work together in teams. One day, these tiny bots could help keep bridges safe for cars and people by checking for damage like cracks that might make bridges unsafe. M-blocks roll, they jump, they climb around each other. Bot M-blocks connect together with magnets to change into different shapes. Large numbers of bot blocks could transform into useful objects, like ladders or carry out tasks. The palm-sized Xano Nano drone Smart Flyer takes photos and videos. You can fly Xano in any direction by tilting a control device. Sensors keep Xano from flying into anything. A group of Xanobots will talk and shoot different views of the same subject together. This one reminds me of a drone. Bots in the future. Kids are building bots. You can build them too. New ideas grow from your imagination. What kind of robots can you imagine in the future? Maybe you want to try out an idea. If you built a bot, what would you make it do? I think this is an excellent question to answer and some good ideas to explore on your own. This 8th grader works on his Lego robotics, Braille printer for the blind. These 10 and 11-year-old robot makers put their Lego robots into action. And last in the book, we have our glossary, which defines all of the interesting words that we learned about in the story. And that's it for robots today. I hope you found this very interesting. I'm going to have an assignment for Miss Jordan's epic class posted to our Google Classroom in a bit for you to complete regarding this story. Feel free to watch the video again so you can learn about each robot again and enjoy your afternoon. Thank you. Bye-bye.